Hello, Mario.
Thank you for joining us on another stream this week. Then today we have Edith and Marcos. I think Marcos is not here yet, but he will join us soon. The topic for today will be MySQL performance troubleshooting with PMM. So um, let's wait few secs, and then we are going to start with the topic for today. But to let you know that this will be our last stream this year, and we will be back in January. Hey, Marcos.
Hey, can you hear me?
Yeah, we hear you.
Yeah.
Great, great. All right. I think it's gonna work now. Jesus, that was hard. Days for hard work.
Yeah, we're a little late, but we were trying to solve some technical issues, but we are now ready to start with the stream today.
Yeah, I'm recruiting one of my colleagues. So our idea for today is to uh, have diagnosing MySQL with PMM. So I have a running PMM instance and a running MySQL instance and some workload that is running on it. What I'm going to do is I'm going to have one of my colleagues is going to log into the instance and he's going to break things that I don't know what he's doing. So hopefully we're going to see anomalies in the PMM plots of the metrics, and with that we're going to work on diagnosis. So I'm just giving him the details to access. Um, just 1 second. There's a running system. Dash. All right, let me share my screen to start with. Let's see how it goes. Screen 2. All right. Share. Oops, can you still hear me? Here it
Yep.
comes again with the
Yes.
connectivity problems. Oh, good lord. Come on. Can you hear me okay?
Yeah.
Yep. Yeah,
We
we hear
sure
you.
can.
All right. And can you see my PMM screen?
Yep.
All right. Everything is excruciatingly slow. My ISP is having some issues, so I apologize in advance for any interruption. I hope it doesn't become too bad. Okay. So here we are. I have where is it? Services, notes, overview. Let me open some other tabs. Basically, I have uh, um, oops, not that. Second, right. Okay, here we are. There you are. And sudo x. So I have this sysbench workload, which is pushing some 70,000 queries per second. And I have uh, one EC2 instance. Let's go to node summary. And you can see it has 16 cores and 128 gigs of RAM. This is quite uh, stock hardware. Like this is a normal machine we work with. So it looks very much like what I will get on a customer's system. And of course, MySQL is burning, very much all the CPU, and Sysbench is only burning like 1.5 cores. So there you go. Um, the idea again is I hope my colleague will soon log in. Let me double check with him. Able to begin. Okay, and I will show you first of all like our methodology, right? Like when we are working to diagnose MySQL performance problems, we follow a well-defined method, and this method is called the use method, which stands for utilization saturation errors. It was created by a performance engineer called Brendan Gregg. He is, really a performance genius. He has published some books, including this one. This is one amazing book. I highly recommend it to anyone that is studying performance analysis. Um, so this is his methodology, and basically it says that a computer has a limited amount of resources. It doesn't have like n amount of resources. It only has CPU, memory, uh, disk, and network, right? So when we want to diagnose a performance problem, what we are trying to understand is what in the system uh, can what resource in the system is the one that has become saturated and is causing the performance issue. So we always start with the node summary because this is where we see the resource utilization, and that will help us understand what is becoming saturated. Um, so my colleague is about to start breaking things, so I'm just telling him he can start anytime he wants. All right. So when I start looking, I of course start with the CPU. This is 50, almost 60% utilized. That's quite a lot already, but it's not like 100%. And I can see that normalized CPU load is about one something. So, and that no CPU core is pegged at 100%. So these CPUs are busy. I can tell CPUs are getting pretty busy, but they are not like fully saturated. I can take a look at runnable process, and this is what is a good indicator for saturation. If I see that the average number of CPU processes is higher than my total amount of CPU cores, then we are starting to get CPU saturated. So the first thing that I will say is, okay, this machine is starting to get a bit saturated with the CPU, not excessively, but it does have some queue. And we can see there are a few blocked processes. This normally corresponds to heavy I/O saturation or to some I/O weight of some type. So with these two in mind, I'm starting to think, okay, I'm going to take a look at things in MySQL that will consume CPU. I'm going to start to take a look in MySQL for things that will cause a lot of I/O workload. So, all right, then I will continue. I will take a look at memory usage. It looks quite stable. This machine has 128 gigs. 128, you said? Yep. So we have still a bunch of free memory. So I don't think this is becoming a concern. And yeah, we can see there's plenty of free memory. Cache utilization. This is the file system cache utilization. It's growing steadily. Usually we have to be careful with this not becoming so large that later when we want to use memory, it will be already utilized by the cache because it will cause some performance problems. The cache memory is reclaimable, meaning that the OS can say, hey, let's free some of this memory to make room for some memory request the user has done. But this still will take time and probably some disk I/O to free this memory. So it's better to not let it use, all the free memory. All right, and you can notice that as I look at the graphs, I turn on and off each of them. That's because, for example, in this one, it's very clear, right? Like I can see the free one and the used one growing up, but for example, the cache one, it's very hard to see if it's growing or not. It just looks like a straight line. But when we see it like this, we can see the clear steep going up. So to actually uh, understand the shape a metric is taking, it's better to turn on and off each of the data series. All right. Swap space, gladly nothing is happening here. We see there was some I/O. It was spiky here, but then it became more stable. And disk reads also has some spikes, but it's fairly low, so like 200 kilobytes, and this is like 42 megabytes. So it's writing. It's certainly a write-bound workload. Then, and this is another great example. Like I can allocate 12 million file descriptors, but looking at this graph, it's impossible to tell what's the current utilization. Looking only at the allocated ones, we can clearly see the shape of the metric. So it looks stable. Again, this corresponds. This looks pretty healthy, I would say. 3,000 open tape file descriptors looks healthy. So I continue. I will take a look at the I/O latencies, under 1 millisecond read latency, and under 1 millisecond write latency. This looks great. Even when we are pretty heavily I/O bound, we can still see the disk is responding in flat time under 1 millisecond. This is very, very good. All right, the write workload is taking about 1 point some CPU worth of time, and the read load is taking 0.01, so almost nothing. Again, another good example of how turning on and off metrics will allow you to more clearly see what's going on. Small bump in network traffic, but everything looks pretty flat. And these numbers are so small. I can take a look here. There is almost not networking. This is because the sysbench is running locally. Okay. So my colleague has done something, and I will start. Oh, there you go. He did something here, and you can see how the disk load plummeted. So what I'm going to do is I'm going to just take a look at last 15 minutes so we can more clearly see what's going on. I can see there are more file descriptors open now. Ooh, what happened? What did he do? All right. Yeah, I don't know what he did, right? So that's the thing. I'm just going to use PMM to try and understand. We can see that something is stopped processing. When you see this, it's not a sign of health. Rather, it's a sign that something is blocking MySQL from doing work, and that's why MySQL stopped using CPU. So this is, oh, look, like everyone is pegged 100%. Look at this. Everybody is pegged 100%. And waiting for something. So there's obviously some wait. I'm just gonna jump. So when I see this, I will immediately jump to MySQL and try to understand what can be blocking. From this particular dashboard, it's going to be a bit hard to tell. because we're not going to see InnoDB locking activity. We can confirm there are less threads running, and MySQL stopped doing whatever it was doing before, so it's really blocking on something. Queries plummeted, everything went down. All right. See, I want to check if any other type of query has spiked at the time of the problem, but no, everything has gone down, so there's nothing particularly growing here. Not this here. And let's see if there is any access pattern that corresponds here. No, either. And then let's see okay, these guys are idle, executing, waiting for lock, also not very popular, open tables. All right, what did he do?
Marcos, in the log,
Yes.
we can see what workflow was stopped, right? It's what we are looking for.
No, this is not a stopped load. Rather, is something is blocking the load.
Okay.
So that's my assumption. And why do I assume that? Again, because I clearly see there are CPUs that are heavily pegged. So the CPU utilization didn't went down. So the load didn't stop it. It's just not able to make any progress. So it's not able to do the writes, or it's not able to do the reads. And so it's waiting, and while it waits, it will burn CPU like crazy, like this. So I know there's something blocking. What I'm going to do is I'm going to switch to the InnoDB details, where I expect I will find more. See? Oh, look at that. See, when this goes down, this goes up, right? So I can immediately go InnoDB locking, bam, row lock wait time. Look at that. See? So my colleague, I'm just going to take my colleague. So you did some row locks. All right. And again, I was able to understand that the load was still there and it was waiting, and I can tell that because this should have gone down with this, but the max core usage actually went up instead of going down. So the load is there. It's just not able to do any useful work. It's just doing what we call spin rounds. And that is why we see everything plummeting, but the CPU max core utilization going up. And based on that, then I came here and I quickly look at it here, and just looking at this row lock blocking graph, I could say, oh, this is likely the issue. So I came to the InnoDB locking panel, and again, I can see that there is more and more row lock wait time, and that is a hint that there is a blocking transaction. At this point, we will need to go to MySQL, and I will do show engine. Can you read the?
If you can make it a little bit
Yeah, absolutely. Yeah, I can do that.
perfect.
Card, there you go. So, oops. Oh, one less n, that will work. And so here we are. Let's take a look what we find here. And oh, I was expecting to see a locking transaction. Huh. Oh, he blocked the commits. What did he do? He apparently slowed down the commits like crazy. That's wow. Okay. Okay, let me go back to InnoDB to PMM, I mean, I still see the row lock wait time is bigger and bigger. Oh, this is even more strange than I expected. It's not simple row locking. I was expecting to find an open transaction, but there's something else here. Let's see. Let's see for disk. Let's take a look at the disk performance now. Perhaps he ruined my disk performance. No, this still looks very good. No, this looks good. Disk operations went down. Bandwidth went down. All right. So what is okay? At this point, what I will start doing is I will start going through these panels to try and find metrics that match the shape or the starting points of the problem. So if I see something that spikes at the same time the problem starts, oh look, logs have sync. Oh look, there it is. Okay, I know what he did, and I think I know how to fix it. I can do set global. Let me just verify select global InnoDB / log at test. Oh, no, that's not the fsync per transaction. How did that increase it? Huh. So it looks to me this is how many times we call fsync for a transaction, and it seems it was going up. But if that was going up, I would have expected this to be 1 instead of 2. So let's continue investigating. But obviously something is doing more fsyncs. And fsync is a very costly operation, so that can break your performance. Right rows right section. Okay. So you can see it's not always so straightforward as we might want, but the data is here, so we'll continue digging into it. And this is funny. I really don't know what he did. So, so this is like working on a customer environment where we don't know what happened. And this is what work we normally would do and what PMM allows you to do. It allows you to go through such an extensive set of metrics that you can really troubleshoot most any issues. It might take time because you have to go through all those metrics. Let me set 30 minutes so I continue to see the dip. There we go. And this KO. What is he doing? Oh, yeah. Number of things. Log is pretty much empty. That's amazing. Pending fsyncs. That's nothing. Okay. And the IO objects. Okay, targets with latency. Perhaps is not something in MySQL. Let me see. I'm starting to think he really made it hard for me. Yeah, this is really good. Yeah, look at that. There is only one CPU ever running. Me, sometimes you want to focus your investigation in a narrow amount of time. And looking at that, I can see there is only one CPU core ever active. So out of the 16, and if I look at here, there is only one CPU active. I think he might have forced the MySQL process to work with only one CPU. So let's go back in time just a bit. Last 15 minutes. And let me just make a couple of minutes, but on the problem time already. So I'm going to leave outside the good part, like when the load was normal. I'm just going to go directly into a problem time and don't look at anything else. So I'm going to take 5 minutes of problem time. And yeah, there is only one CPU running, which is really weird. That is not normal. There's a bit of a steal there. Oh, let's say wait. And yeah, look, there is one which is like melting down. It's totally melting down. It's doing all the user work, and the rest are just very much totally idle, right? So okay, let me. I'm my colleague, and I'm gonna take a guess on this, but let me show you from. So at this point, again, sometimes you need to look at Linux tools, but if you have the clue that there is only one CPU being used, you might want to go back to your Linux and just do a quick top, for example. Yeah, MySQL is using only one CPU because otherwise we would see like 800, 1000 here. And big-x MySQL d cat 229 CPU set. No, what is CPU affinity? Affinity task set. That's it. Task set. And that's be 27 to 29. So yeah, I think he pegged me. I'm just gonna okay, and let me remind myself how you would. So he's and you can see it's number 2. So he's pegging me to CPU 1, 2. So it's only using CPU number 2. So what I'm gonna do is I'm just gonna fix that -c 0 to 15. Oh, what do you mean? Oh, it's that weird list. Task set dash task set dash e 27. Oh, I never remember how to use task set. I'm sorry. Give me 1 minute, please. I think it's like that. Huh. Okay. 0x. Let me remind myself how to use taxset, which I never do, and mask. Okay, p mask fit. Look at that. That's weird. I knew. Exit. There you go. And we should see this guy going up very soon. Let's see, last 5 minutes. I think what I did should have fixed this. Let's see, you see the utilization details. Not yet. All right. I'm sure it's that. I'm sure he did that. F should be, oh. Except P V 0 Okay. Okay, so I was using just 0 to 3. Now I'm using 0 to 15. Okay, that was the right syntax. And he confirmed that was what he did. So we should see our CPU utilization going up very soon. Up. And MySQL D is still not picking up. Did I got the right? Oh, that's weird. Okay, I'm hoping this is gonna recover, but it's not recovering. Just why is not giving me back my CPUs? I get the impression he did something else. So at this point, what I'm going to do is take a look at and see if I can understand process details. All right. Okay, percentage. Sleeping, disk sleep. Yeah. I guess he did it for every thread in MySQL. What did he do? So this is the funny part, of course. I hope you guys are finding this interesting, and if you have questions, please post them on the chat, because you know, I love this kind of diagnostic. I do it live with customers, and I think so. Let me show you a bit more of Linux, because you know the problem he put. I was able to detect and understand the problem in PMM, but to actually solve it, we have to resort to Linux, right? So I can see CPU utilization is improving somehow. but still not what we want. So what I think is happening is this guy, he did it for all of this. So one of these for E and system star to done. So Linux is basically the Linux shell. Very much any Linux shell is a programming language, and it's meant to do these kind of things. Echo I, there we go. Oops, semicolon. So what I'm going to do is task set dash pc 015 and then the PID. All right. And there you go. Fix it.
Yeah.
So
Summarize what
there you go.
yeah.
No, go ahead, please.
Yeah. Could you summarize what you did?
Yeah, of course, of course. So in the Linux, there is this magic folder called proc. Basically, it's a convenient way to access the state of each process running in the system. So my PID is 11.528, right? So it's here. And if I do cat proc 11.528 x no, sorry, cat no, ls-lha, you can see it's running bash. Or if I do it for 27.249, it's going to be MySQL. So it just gives you information about each process, and you can access a lot of information. Under each of these, if the process has more than one thread, you're going to have a subfolder called task. Task. Yeah, task. So each of these is the thread ID. So we have the process ID, which when you do top, you can see the process ID here, 27 to 29. And at the same time, the process has sub processes which are called threads. So when I initially did a task set for only the main PID, it was not automatically taken by the subthreads. So to correct the whole problem, I had to actually do it for each of the threads. And for that, I just repeat the command for each of the numbers. And of course, instead of doing it manually, I just did this very quick for loop that allows me to iterate over each of these numbers and use it to run the command. So, and that way I just reset the affinity for each thread and things went back to normal. Okay, I'm going to ask him to break it again.
Yeah.
Break it again.
Okay, we have a question.
Of course.
Let me read it for you. Yeah, it says we use PMM for sorry, we use PMM for our daily troubleshooting. It's a great tool. In the red dashboard, we don't have any data for P99 query latency. How do we troubleshoot it?
Wait, let me see if I. Okay, Tanu, it is great. In the red dashboard, we have. Okay, P99 query latency. So first of all, you need to enable the query response time plugin in Percona server. So that functionality depends on an additional plugin in Percona server. It shouldn't be too hard to set up. And if you look at the PMM documentation, you're going to find, let me see if I can very quickly find it for you. Query. No, yeah, here. Um, no, it is in the manual, but you're gonna have to look for the Percona server manual itself. It's not in the PMM manual how to enable that plugin. But again, what you need to have query latency information is that plugin, the query response time plugin. So that is the name, query response time, QRT. It's part of Percona server. It's free. You just have to go to the manual and find the instructions. It's basically install plugin query QRT underscore something. I don't remember top of my head. I'm sorry, but that's what it's gonna get you going. Okay, I'm waiting for this guy to break it again. Gonna drink my mate if you don't mind. Let's see what's going on in our world. MySQL summary. Not last 12 hours, last 30 minutes.
Who is breaking the server, Marcos?
It's Nikolai. Nikolai, who is. I knew he was going to be a good candidate to do it. He has quite an imagination for breaking things, so it was nice to ask him. Again, it was super interesting, and again, it allowed us to see how the dashboards in PMM contain enough information to actually allow us to understand where the problems might lie. And here when I saw just one CPU super high and the rest super flat, I was like, okay, there is a limitation. So he wasn't blocking the MySQL load, he was blocking the CPU access, which it was quite unexpected, to be honest. Okay, any more questions? Let's see.
And in LinkedIn, they say this is very insightful. I'm engaged actually in the problem now. So that was a good fix. And Michael Villegas say, oh man, well done, Marcos. It's really great to
Thank
see
you.
you through the problem.
Thank
Yeah,
you.
we have
Yeah.
another question. Yeah, it says, is it possible to list the process name which is causing the high CPU utilization in PMM?
Wow. So there is a process. Let me go find it. Processes. There you have it. And if I recall correctly, there is the number of PDs. No, I think it was removed then. Let me see if it's in the Data Explorer. We used to have something like that, but I think it was removed. But it might still be. There is something called PMM here. Where is it? Search dashboards. OS. No, process details. Advanced. There is an advanced data exploration, and I think through that you can actually get the information. Let me check. I just PMM 231 changed it dashboards quite a bit, so just let me find it. Jesus, what did I do? Let me see. Bear with me, please. I hope they didn't remove that. It would make me very sad. Like, gonna have to go back and ask them to put it back in there. Here it is. Okay, transit data exploration, and I think process IO, process open file. No, they might have removed the thing entirely. We used to have like the top processes, so you will see which were the processes. Let's see, PID, PID, yeah. Um, no, no. It used to, again, in these, in older versions, at least in the process details, we used to have like top PIDs. Let me make sure I didn't went over through that very quickly, and it will show you like top 10 PIDs, and that was what you could find here, but it's obviously gone. Threads. No, it's gone. Again, older versions did have it. It's useful. I guess nobody uses that very often, and it's not very cloudish because if you're in Linux, we expect you can just go ahead and do top. And if you're in the cloud, there's nothing you can do about those processes. So, like you will be running in a dedicated MySQL instance, so it will make sense to see that it will be always MySQL, right? But yeah, you could take a look back on older versions and see what was exported and just re-implement the dashboard if you really wanted it. But it's a shame. Yeah, it's a shame it's not there. Yeah, it must be gone because let me see if it's not in the overview, just out of curiosity. No, these details, memory. No. So let's see. Okay, my colleague has broken MySQL again. Let's see. Oh, what did he do now?
Wow. What's that?
No. Let's see. No. All right. Let's do last 15 minutes only. And let's see how things change it. Okay. So it should have been like the last 1 or 2 minutes. I guess this is where things started going bad. All right. So we can see, again, I'm going to start with my OS node summary. I always go back to this, right? Like I make sure that I have the right node selected. I'm going to start going right, like, okay, CPU looks normal, no I wait, no still. Let's make last 15 minutes. Sorry. So again, we can see the load plummeted, and look now the CPU plummeted and the max core CPU utilization also went down. So, but he's creating more forks. No more blocked processes. All right, let's see what we find. So it doesn't look, it's the CPU. Right. IO activity also went down at the time. So this is when we recovered it before from the CPU issue. Okay. IO is good. There's no additional network traffic. There is some additional network traffic. he might be running additional load, perhaps. We will see. Oh, so there were a bunch of retransmits, and suddenly it went to none. That's weird. All right. Let's see. Let's see. So I can't immediately infer what's going on. I can tell again something might be blocking or preventing things from completing fast enough or from connecting fast enough. Number of runnable went down, which is a bit unexpected. All right, I'm just going to turn to the MySQL instance summary. So I always go to the node summary first, then I go to MySQL instance summary, and then I go to the InnoDB details. So that is the order in which I always visit these dashboards, and I think it's the best approach. So I will advise to do that if I was trying to diagnose a performance issue. So it was doing, a bunch of queries per second, and it plummeted. So we obviously have a performance issue. No wanted connects. There are no additional connections, but threads running is permanently higher, right? It was like in the 13, 15, like it was going up and down. Now it's more stable at 18, 19. So there's obviously something that is keeping the threads running without actually being able to do much work. Okay, the thread cache is more heavily utilized. So everything is plummeting here. Again, look how I will turn on and off the different data series on each panel, because again, in this case, you can take a look at the numbers and see they're very low. But with something that goes into the 25,000, select range, the range could be 10 rows, and then it's not a problem. But a selected scan is usually a problem, and it's easy to fix because you just add an index. So I want to check if there are selected scans, even if there are not thousands, if there are just a couple of hundreds, they could be bad. So again, always remember to focus on a small piece of time. I'm just focusing on 15 minutes. I take a look at the place where the problem started and just a bit before to have reference of what's normal, and I take a look a bit after to see how the problem develops. And then I will again turn on and off individual data series to more easily see the shape of each. Sorting remains the same. Okay. Table looks weighted remains at 0. Okay. So, and these correspond to the type of queries, select, update, start transaction, commit transaction, insert, delete. I see none of them actually went up drastically. They all plummeted. And I'm going to check these ones. This is each of those queries. A single update could be for one row, or it could be for a million rows. This is telling us about row activity. So row activity here also, everything is plummeting. All right. All right. So these are just the small spikes. It's like under 1 per second. So of course, there is nothing that could be under 1 per second. We're just averaging things out. Like if you use 1 second, then we're going to see that there should be at least, well, not even 1 per second. That's weird. This seems an anomaly in the metrics. I believe this metric is only taken at 5 seconds interval. And so you have like 4 per second, and that just happened once in the 5 seconds. That is getting averaged out. Right, what else? So this is the state of the threads. A spike in a state can hint us about what's going on, what's blocking, what's not blocking. right, that's curious. Query cache, open files, no spikes. There are no misses due to overflows. Openings, all right. Let's see here. Table definition cache. That looks all nominal. Okay, that's okay. So, I cannot yet see what's going on. So I'm going to go to the InnoDB where things are normally more interesting. I'm just going to focus last 15 minutes, please. There you go. Again, we still see the normal time, and then we see the problem time. It's always important to have a bit of reference for both visible, or I find it important. Actually, let me now let me apply the range. Yeah, that's better. So here is my first hint, right? I see again row lock blocking spikes up at the time the problem happens, and there are more buffer pull requests for each row that is being read. So he either created a table, he added an additional workload, and we're going to find out. I'm telling you, this guy has some imagination to break things. He is really an amazing performance engineer. So it's funny to see how he thinks to make my life miserable. Now, this is super fun. I love performance diagnostic. This is super fun to have like a problem that does not appear obvious, but it must be there, right? Like I start to see the signs of it. I just don't have yet a solid theory on what could be. Right, storage summary. Oh, look at that. It's growing in space. Oh, oh. Could it be he is keeping a transaction open? Yeah, he's keeping a transaction open. That's what's going on here. So there is more disk space being used. I can see it growing, right? Like it's going up. Yeah. So it's not like in the gigabytes growth, but it is growing. Space allocated. Okay. Log write requests. So he's writing big rows, or writing bigger rows, but not sure how that could block all my traffic. Log written. That's smaller. Log IO. This remains low. Fsync. Log fsync. Maybe 5 views. Objects. Double write. Temporary. No, all have lower. Okay, so no weights in there. Data files. No, everything went down. These pages. This looks normal. Okay, let's see the buffer pool. What's going on? PP right buffering. I think he added an index. No, that cannot be it. Did he disable the change buffering? If he disabled the change buffering, I'm going to find it here. So it's a matter of waiting. No, this looks pages created. That looks normal. Sorry for that. Oops. Okay, let's see. Checkpoint and flashing. No, it all plummets. No, again. Load buffer. Oh, load time, load time. Group commit sync delay? Nah. Whatever he did is causing the commits to be delayed, so they create bigger groups. Blocking. Now there is a lot of like 700 milliseconds roadblocks. That's quite a bit. Like wait timeouts, they're non-happening. Deadlocks, non-happening. Wait load. So there is row lock waits. That means transactions remain open for longer time, holding locks, but space. Let me do last 30 minutes. So I'm sure I'm looking at the problem time because the problem time is going from the graph at this point. It was at 11:52. So there you go. Let's purge. Max transaction history length. Those transactions are longer. Still can't find it. Wow. Page splits. That looks nominal. Wow. Okay. So, oh, but that was from before. So not the adaptive hash index. Change buffer. No additional change buffer. Yo. Wow. Okay. Oops. Sorry. Just gonna finish with the InnoDB. I'm gonna go back to my node summary because it's gonna. Let's start over. You know, when you don't see the problem, well, then it means you're looking in the wrong place. But hmm. Load. Let me think for a minute. Where's this details again? Well, well, Nikolai, you made it hard enough, for sure. This looks okay, wrong pages. Well, you can see, doesn't have swap here. Let me, what am I missing? I must be missing something, which makes it even more interesting. Let me think for a minute. And go back here. Let me start over with this one. He really caught me here. Okay, buffer. No, it's not the volume of writes. Oh, what about your buffer volume? Um, okay, this all looks perfectly fine. Wow, he really got me. Um, Let me think for a second. Performance skill. I'm not sure I have query analytics enabled. I'm not sure if I enabled query analytics on this. No, I didn't. Oh, come on. I failed to enable query analytics. Um, so let's take a look and see if I can find any weight that will explain things. Uh, and to answer, so Nikolai is trying to give me a hint, but and he's asking me, what is the first thing you will look at in yeah okay yeah so
Where?
he's asking, yeah, I should take a look at show process list. I guess I have a clue now. Let me see if I can find it even without QAN. So he's asking me what I would look at if I was MySQL DBA with access to a command line interface. The second thing I would look at is either show ancient InnoDB status or show process list. And of course, I would be able to see this through query analytics, but he's telling me, yeah, without query analytics, it will be hard. So let's see if with 1 second resolution, I can see it. No, I guess he's running an alter table or. Okay, let me go to the process list and see if I can actually find it. Oh, funny that he's doing this. Okay, so with query analytics, this was my bad because I set up this PMM this morning, and I thought that when I set it up, I actually enabled the slow log, but obviously I failed to do it. Um, with query analytics, I would have seen this query started appearing at the time of the problem. This query is sleeping 1 second before doing the insert, so it's just a silly query he built. That will of course be horrible with performance because every insert is going to take 1 second. uh, okay, so again, you will have had the data with query analytics. It was my bad that I didn't have it. So with query analytics, I will have been able to come here and start before the time of the problem and then after this time of the problem, and actually see, okay, this query is only started appearing after the time of the problem, and I will start looking at the performance of those particular queries. So that will have been also possible to diagnose if you actually configure your PMM properly, not like me. Uh, okay, I'm not sure if we have time for one more. I would love to do one more if you guys want. And if Nikolai can break it again for me, I will be joyful to do one. Do you guys want to do one more, or is it too late already?
No, I think it's okay.
Yeah,
It will,
why
All
it
right,
not?
will be interesting to see one more.
Yes.
all right. Nikolai, break it one more time, please.
So what was the difference between the first issue
No,
and the second?
so the first issue, he reconfigured the operating system, so MySQL could only use one CPU core out of the 16 that were available. In this case, he is changed the workload so that the queries were actually so slow that they appeared to be doing nothing. So they appeared to be blocking, but they were blocking just because they were in sleep. So if you do select sleep one, you're not doing much work. It's just sleeping, but it takes 1 second. So the throughput of this is never going to be very high because you are forcefully sleeping 1 second. So his workload is artificially bad, and it's just funny to see that. And you can see that we're all doing user sleep. Oh, damn it! I should have seen that here. Why I don't see that here? You know, process states other. Oh, it's segregated under other, I guess. Executing of statistics. Oh, well, I'm gonna report a bug for PMM because I should have seen the user sleeping here, right? So you can see that the state, is updating, waiting on MTQ, waiting for handler, whatever, um, and updating, waiting for log. You should see all those states in here. Apparently, the user sleep becomes aggregated under other, and that's why I couldn't see it here. What a shame. So I wasn't that far because I went through this graph looking for thread states, and I didn't saw any that would caught my attention. But obviously, if I would have seen user sleep, I would have realized that that was a problem.
Yeah.
Right.
Nice.
Let's see if Nikolai put it back to normal. Let me do last 15 minutes. And MySQL questions. Here it is. Okay, you come back to, let's do last 1 hour and see the different shapes. Oh, no, it's still low. So yeah, it should be like 72. Just 1 second, please. Uh-huh. All right. While Nikolai finds another very imaginative way,
We have one question there.
yeah, I see. In query analytics, the explain plan breaks at times for me. Gives syntax error. Is there a solution for that? So, Apurv, you're probably using performance schema as the source for the query analytics, and performance schema will have a limit on the length of the query example. So it can happen that if your query is super long, let's say longer than 4,000 characters, the last couple of characters will not show up, and that will cause the explain to give you a syntax error. I think we have a blog post article on the subject, but basically you need to increase the the you need to increase the length for the SQL text in the performance schema statements table. I can't recall top of my head. Like I will need to go and check the performance schema. So and of course I'm gonna so Nikolai told me, oops, that he's doing the inserts with a trigger. That will have taken some additional time to troubleshoot. Like once we find where that the query is being executed, so where does that query comes from? It will have taken a bit of time. Triggers are always a source of mysteries. Uh, it's a side effect on your actions on the table. So many times we do things with triggers, and those things bring bad performance. Um, and it's never easy to locate those. So be careful with what you do with your triggers. And show global variables. This performance schema max SQL text length. That is the variable you want to increase. That will limit the size of the SQL text in the table. And so if your query is 1,028 characters, it will be cut at 1024, and now the syntax is going to be invalid. I hope that makes sense to you. And let's see, things going back. Yep, there you go. And we're back in business. So he is preparing the next trick. Let's give him 1 or 2 minutes, please. In the meantime, again, if you have more questions, I'll be glad to answer as many as I can. I don't have the blog post link handy, and I prefer slow query log. It provides more detail. It also includes the log time. The performance schema timings do not include the row log time. So if you are suffering a lot of row logs, query analytics will not reflect that when you use performance schema as data source. And also, you will never get truncated queries in the query analytics if you use a slow query log. Again, you don't need the blog post. Just you need to adjust that variable. Performance schema, MySQL text length. Okay, this is looking good. Top-notch performance. Let's see what happens. All right, and let's make this every 5 seconds, so we see those changes faster. And out of curiosity, I have a question for the audience. What topics would you like us to show more often? Like performance, operations, troubleshooting, more low-level stuff, more developer stuff. I always curious about what people actually want. We try to make this interesting, but I guess it will be even more interesting if we are actually showing what you guys want to see. So
Yeah, leave your comments on our social profiles and let us know what topics you would like to see on our future live streams.
In
yeah,
2023. Because
Yeah,
this is the
yeah,
last
yeah,
for last year. Yeah.
this is my last. This is the last of the year indeed. Uh, I'm gonna be I'm gonna be gone from here to end of February. So if you have
This,
questions, you better ask them right now.
yeah. Christmas
yeah.
gift. Thank you, Marcos, for this.
Yeah, my pleasure. I'm sorry we had to cancel the other Friday. It wasn't a great time. So glad we could reschedule. I'm looking. So PMM 231, which is what we're using here, brought a lot of rework in the dashboards and the homepage. So I'm just taking a look because I didn't have a chance to give it a good look with some actual workload. So I'm just going through it. So this anomaly detection is new. It's I guess 90% might be a bit high. You can always adjust this. Oops. You should be able to edit the JSON if you want. So, oops. Uh-huh. Right, memory consumption is under 80%. And command center. And this is nice, right? Like if you had a farm of servers, this will be showing you, okay, these are the top 20 CPU consumers in your farm. So you're not looking at a single server, and it helps you locate what servers are having issues at the time. So this is kind of for people with a lot of instances, it's going to be very useful. And of course, if you have like weekly data, it will um, show you historic trends, and you can see it's trying to get data for a week. So with the historic trends from a week, you are able to compare and say, okay, this is normal because all the previous time it was like this, or this is an anomaly. We should go take a look at this machine because it's not behaving like it was last week. So this is quite useful. Again, the same for memory and read latency, write latency. And these are our top indicators, right? CPU, disk queue, the disk queue. When the average queue size in storage goes above 1, we will call that disk saturated. And with saturation, basically meaning adding more work to that storage device is not going to make it come out faster or deliver more throughput. Um, So when you see your disk queue growing above 1, you can tell it's starting to get saturated. So this is our go-to metric for I/O saturation. And of course, then read and write latency and memory. So these are like very good metrics to have a quick glance at. This should be useful for anyone doing performance analysis on a large data center. And okay, this is a nice summary of what's going on. Like if you have your list of instances, telling you DB connections, the QPS, and the uptime. Like again, basic status metrics. That's useful. Uh, Playlist, Spotify playlist. No. Right. Let's see what other. And I can't recall who was asking about P99. This this dashboard also depends on that same plugin, and it includes the dashboard itself includes information on how to install it. Actually, the plugin is not available for 8.0. Sorry, I'm getting called for analysis. And if you like to do this kind of performance analysis work and you're looking for a job, you might want to postulate yourself, apply for a support engineer position at Percona. Explore. Let's see, explore. Okay, that's Metrics Explorer. Again, a lot of changes here, and table details. I have it enabled. Yeah, fantastic. Okay, I hope things are broken by now. Let's see, summary. Come on. I guess last 30 minutes. All right, I see things are getting peg it here. Oh yeah, there you go. Things are definitely broken now. All right. It just hit a wall directly. It literally hit a wall. Just 1 second, please. Right. So again, I will start like always going back to my humble nodes summary. Hold on. OS node summary. There you go. All right. Node name. That's my node. All right. So CPU utilization goes down again. You can notice Nikolai actually likes to use the trick of tricks that actually result in less CPU utilization, which is contrary to what most people will expect. Like most people will expect CPU spiking, and that will be the problem. Here you can see actually CPU goes down, and it's the problem. So those are usually, yes, the most interesting problems. There is a spiky in IO. I don't know what he did. We'll find out. Still, okay. We can see again, CPU went down here, but there is a single CPU that got pegged very heavily there. Runnable process remains somewhat stable. There was, oh, the problem is gone. So I have to ask Nikolai, it was a transient problem and it's already gone. And this is a root cause analysis for this small gap. Or is the problem still ongoing and just became less notorious? In the meantime, I'm going to assume the problem was a transient problem, or that it's going to repeat itself. And then when it repeats, it's going to look like this, like a deep inactivity with some CPU that gets heavily pegged. Block it, block it. Okay, so he's telling me that there will be a periodic performance drop. So my assessment was somewhat correct. You know, we're going to see more of this. Right, those are even more interesting. Oh, look at that. IO latency went to hell. So something is writing heavily, like 200 megabytes. Wow. That's some writing. Okay. So at this point, I already have a clue. I'm looking for something that produces writes. And this is why we always start with the node, right? Like we try to understand what's going on in the machine because on the machine resources, because that should give us clues about what's happening in MySQL. So, okay, something is doing like, you know, five times the normal amount of writes. And this is happening afterwards. I wonder if it's related. I don't think so. And yep, there you go. More network stalls there. Okay. Let's go to instance summary. Last 15, is it 15 minutes this? If I do last 15, do I see it? Yes, if I do last 15, I should see it. All right. There is the dip in the QBS. So there was a notorious drop. Threads connected, looks normal, running. And this happens 12:38. All right, then. Some queries, questions. Everything is already blocked. Oh, look at that. He's doing an alpha table. So again, let me do. Oh, I have it in 1 second. So what I find is that at the time the problem starts, there is an alter table, and an alter table, depending on the type of DDL you're running, it's going to block everything, right? So might not be only the alter table, but that's obviously related. And there are conkill. I'm not sure if that is like. I still don't have a reoccurrence. I think one is about to happen now. When you only have one occurrence, sometimes it's hard to be assertive about all the causes of the problem. There are also admin commands. This could be comping. What else is an admin command? Let me check. Always have that written because I never remember. Obviously, there is this series of things happening around the time of the problem, and so this collection of things are obviously related with the problem, right? Like they happen exactly at the time of the issue, especially the com admin commands. Com admin, let me find it very quickly because I don't really remember. Okay, our customer Nikolai is telling me the problem is happening every 10-20 seconds. So it's more subtle and it's not this massive drop in performance. Okay. So, so I will have to ask my customer if the performance they notice is that it goes from like 70,000 queries to 61,000 queries. So, which is like a solid, 15% loss in performance. I would be worried if that happens like every couple of seconds. So, Nikolai, can you confirm that? Okay, so it's that, yes. It goes down to 50. So the selects in particular, that they go from 50 to 45. Again, it's losing like 10-15% of performance at times. So that is the problem as he's described by the customer. So it's not this big dip. I misunderstood the initial explanation of the issue, and this big dip is not the problem. Rather, the problem is these smaller dips that happen recurrently and don't allow the performance to be stable at the previous level. You can see this was like 10K, 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 and it was steadily going at 10, almost 11. Here it goes 10K, 9K, 9.6, 10K, 9.7, 10K, and it goes up and down all the time. So that is what they notice as the customer is noticing as the problem. Okay, it's nice that I can have some clues about what happened here, right? Like he did some alter table, set some options, but I don't know what options he set yet. Shows the status. All right, let me last. Just 1 second while this reloads. Apparently, it stopped my PMM. Oh no. Yeah. So, did you broke my PMM, Nikolai? I guess. Select types, yeah. So it's able to fetch some things, but not all of them. What's wrong here? Okay, I see there are heavier number of selected scans occasionally. That might, and there are, I guess this is just monitoring side effect. Okay, questions. I don't know why I stopped it, like I lost the command counters. Sorry for that. And they are all suffering the same. Right. There are more threads to an update. I guess he removed an index. No. Waiting for lock. Okay. Okay, well, none of those is gonna help me. Let me go back to 5 seconds resolution and see if I get back my metrics, because come on. Open files. Okay, can't find it here yet. Let me take a look at IMDb. Go IMDb details. Mhm. He obviously created some big table. I assume he created the table because hmm. Okay, story summary. Oh, hmm. Optimized table. What happened there? Uh, Space usage. So there was more space usage. We, hmm. So did he fill it up the buffer pool? Let's see. Mhm. Perhaps he said NDB flash logger T-Rex commit equals 1. Let me see. I don't remember. Is it in login? Yeah. Oh no, still every 1 second. Hmm. Okay, let's continue little by little. Pending IO. Yeah, negligible. Hmm. NDB IO objects. All right. Found.
We have another question
Uh-huh.
from
Let's see.
Mahendra. Mario, did you see it?
Yeah, again, it could be large transactions keeping things blocking, or it could be that you increase the durability, and so now the problem is the I/O and not the CPU. I see this increase in X-test pages. These are the file descriptors, so there is something growing on disk. You know, that's my understanding. And there was a big uh, increase in the amount of stuff in the buffer pool, and it got a lot of data flushed. So there is more dirty than before, and there is less free than before. Still plenty of pages free. A lot of pages created, which matches the increase in excess pages. There is a heavy increase in pages written, right? Like from 600 to 1000, 1100, you know, so almost double the amount of pages written. Pages read remains stable. Good. Pages flashed from flash. Flashed per batch. So there is more flashing, but I don't know why. So there is more adapted flashing. So perhaps he increased IO capacity. No, he didn't increase the IO capacity. Did he reduce it low watermark? Pages flash. So again, this will cause performance, like unnecessary flashing or too early flashing. It's bad for your disk and it's bad for your performance. Okay, sync flashing. This just was some very big write he did. This was just very punctual. Background flashing is what we like to see instead of adaptive flashing, but you're only going to see it if you're very lightly loaded. And LRU flashing is what you will see if your buffer pool was too small to fit your data. Okay. Right ahead. Doc right amplification. Just 1 second. Loading performance. Search. So there is certainly more double the load on the right on the redo load. Just can not tell why yet. Wait. Perhaps he changed the size of the no 4 gigs is still okay. Okay, this is also very low. First manage. Change buffer. Well, I can tell you, Nikolai, problems are harder than customer problems. All right. So I'm gonna have to start from scratch one more time. Wow. Yeah,
Okay,
this one's
we
hard.
have another question. It says, is there any graph in PMM that shows metadata logs on the MySQL server?
No, you will see that in contention, I guess. But no, there is no non-specific to show. It wouldn't be a bad idea to have those. Like in all honesty, that you can implement. Like in MySQL 8, there is a metadata logs table in the in performance schema, and you can write a custom exporter to actually have that number, and then you can simply plot the number of metadata log weights that are happening. It shouldn't be too hard to implement, but we don't have that right now. This one's really hard. He really got me in this last 30 minutes. Bad part is I'm gonna have to wrap up in a couple of minutes. I never thought it was gonna take me this long. Uh, last 30 minutes. Well, actually, if you see table logs weighted, that is a metadata log most times, unless it's an auto increment log weighted. But this would be a metadata log. So you can probably infer those from here. again, there is something that is aggregated under other, and I cannot see the actual thread state. That pains me, and it's the most popular thread state. Yeah, Nicola is telling me that what I was telling you earlier, that it's best to focus on smaller pieces of time and just use 1 second resolution. So join. Hmm. Statistics. No, these are just too small. He's importing data every 20 seconds. He's bringing in more data via load file or something. He is opening tables every time. This is weird. Why would you reopen tables like that? I would really love to know what this other here means. Hmm. All right, complex. So yeah, he's jumping. So what was the norm? Let me duplicate this tab. And I'm gonna go back 1 hour just to see what was the insert rate before, right? Last 3 hours. It's fine. So the number of inserts grew. So he's inserting 32 rows, and you can see those inserts 30 rows at a time. So again, it looks like he's doing load data into file on file. Oh, Complex. Yeah. So what I will do is again try to I would do a query audit at this point and try to understand what is causing. So it was doing 2,000, you know, inserts per second before. So this was normal workload, right? And you can see it was doing 2,000, 3,000. This was my normal workload before. And when Nikolai started playing around, it was like around this time. And now you can see it goes up and down, and it goes between 6,000 and 30,000. So it is related uh, to the inserts, to the volume of inserts. It's just that without the query analytics, I cannot identify the query. So again, I will go back to show process list, list, show process list. Commits. It's a lot of commits. Distinct. So there you are. That kind of queries. Those will actually insert thousands of rows probably. Like I will. This has no condition, so what I would do is select count. Oops. And yeah, so he's inserting 300,000 rows at a time, and most certainly this insert is the problem. So we can go ahead and just do where is that insert coming from? I guess he might have done that in some other trigger. I don't know. Like I would, at this point, when you see these kind of things, you need the developers or someone that is aware of why queries are running. So in this case, I will ask Nikolai, our resident developer, if he knows where this query is coming from, and just ask him to if we can get rid of it. And we're gonna and I guess it's gonna come back in a couple of seconds. We're gonna see that free in items. Well, that's one particular state to me. Again, I guess we should see that insert select coming back at some point. And let me see, show engine. Of course, this is not in PMM, but again, sometimes you have to come back to the MySQL terminal and take a look at show engine or show process list, or actually work with a query log through query analytics.
Apur said, looks like the insert is running in the infinite loop.
Yeah. Actually, I don't see the insert coming back. So Nikolai says the insert has been done for some time, and it's not actually the sole problem because they had that insert before. Okay, let's take a further look. Pending fsyncs. I wonder if there is like some heavy disk latency now. Last 5 minutes. 1 second. No, sorry. Okay, in 9 minutes I'm gonna have to give up, so I hope I can find it before then. So he's making an index visible and invisible? That would be weird. Yeah. He's making indexes invisible. Funny thing. Okay, that was quite an imagination, Nikolai. Fair enough. All right, folks. I'm gonna have to give up on this one. I think, but you know why I don't see those authors here? Like I would have expected to see more of those here. Um, in the last 5 minutes, let's say I'm gonna do 1 second interval. All right. Uh-huh. So, and I don't see the alters. Again, with query analytics, I think it will be easier to spot these kind of issues. So Nikolai, that was the actual issue, right? Like those alter tables that uh, are making the indexes invisible. He's writing to me in the internal chat. I'm sorry. Yeah, okay. All right, yeah. So that is indeed what is causing the performance fluctuations. Because if he's not dropping the index, he's just hiding it. So queries that will depend on the index, of course, they will become slower. All right, folks. I hope it was useful and that you find it entertaining. I love performance diagnostics, so I really enjoyed this. Thank you so much, Nikolai, for giving me trouble. I really, really appreciate it. And I will see you, all of you, next year. I hope you keep coming to us. All right. And
You, Marco.
I
We can
see,
see you. We can see you.
I see, I see there is any possible to list the process name which causing the this Yeah, this alter table will be caught in the slow query logs if you have long query time equals zero. So it and when you have long query time equals zero, you need to do rate limiting. So it might take some time to show up, and it might, the problem is the alter table is very fast, so it's not going to come up high in the list. Um, it's what you will see is that the queries in query analytics will have a dual profile. So they will run sub milliseconds sometimes, and they will run in a couple of milliseconds in other times. And that is telling us that sometimes they run with the index, sometimes they run without the index. And that is the that could give you a hint. I would be looking for some other thing. It's really uncommon that someone is disabling and enabling indexes like this. And Nikolai just replied to you. Uh, Waiting on metadata log. Yeah. So he suggests that the right way to investigate will be looking at metadata logs because the alter does need access to the metadata. Okay, folks, pleasure having everybody here. Thanks for having me, and I hope to see you next year. Have a good one, everybody.
Thank you,
Thank you,
Marcos.
Marcos.
See you.
Most
Thank
welcome.
you.
Go ahead, Mario.
Yeah, thank you, Marcos. It was interesting to see you troubleshooting with PMN, and thanks everybody who stay with us for about 2.5 hours.
Yeah, it was an
And
extensive one.
yeah, yeah. So, well, we took some notes about the topics that you want to see, but also if you have any suggestions for future streams, let us know, and we will see you next year. So thanks everybody. Yeah.
Yeah, thank you,
All right.
Mario, Marcos. See you next year.
Bye now. Ciao,
Bye.
ciao.